I just thought I would add a quick little intro to the start of this video. I don't normally do these, but I think considering what I was talking about, I should probably explain what I'm doing. I'm going to be looking at easing today, which basically involves the smooth movement of objects based on predefined mathematical functions. To give you an idea of what that looks like, here is the example of what we'll end up with. I'm going to be easing this object just up 2 units. You can see how after a 2-second delay, which you'll see later, the object moves slowly and then speeds up nice and smooth. That might be a little hard to see, but that's what we're going to achieve today. So if you watch the rest of the video, this should be the end result. It's been a little while since I've done a video. I've actually been preparing for my wedding and doing some uni stuff, but I decided I had the afternoon free or the evening free, and I wanted to make another quick tutorial. Something I've always been interested in is easing functions and easing classes. So for those of you who don't know what easing is, it's just moving an object in a nice smooth arc from one point to another, basically. You can do that with many different algorithms. I'm going to be using an example from the MSDN easing classes that use a power ease. So, that we just raise a value to a power and make it move from one value to another. One of the issues I have with doing easing is anytime I want to ease an object, I have to set up a timer and a coroutine and check that my timer's running and move my object, and I don't know, it bugs me. I don't like the way that works. I like to write code that is nice and reusable and easy, and I can just call it once and it's good to go. So I've just set up a few folders here. It's just the way I like to set up my projects. So in my scripts folder, I generally have any sort of in air quotes library that I write goes into utilities. I'm writing an easing class, and I keep the base class in its own folder so it's nice and easy to find. So the first thing I'm going to do is create a C# script, and I'm going to call it easer. So I'm going to make an easer object, and this object will be responsible for moving any actual object in a scene from one position to another over a specified amount of time. So I'm not going to go into too much detail about why I'm using certain variables. I've just mucked around with it, and this is my implementation. Of course, that doesn't mean this is the only way to do it, or it's even necessarily the right way to do it. I just thought this was a nice way for me to solve a problem. So the first thing you'll notice is my easer is not mono behavior. It is going to use a coroutine, so I will need a mono behavior, so I can run a coroutine. But I just don't feel like I need to add a script to the object to do this and constantly have to add it and remove it or reset it and do fun stuff. So I'm just going to use a standard C# class, and I'm also going to be forming some inheritance to make this work. So the first thing I'm going to do is I'm going to create an enum, and this is called enum. I've called it easeType, and I'm going to give 2 different values to my easeType. So the first is going to be in, and the second is going to be out. So one of the things I thought about was when I'm wanting to ease an object, what are the 2 different types of ways I'm going to want to ease it? There's generally an in and an out version of the same mathematical function. Now, as I said, I'm going to be creating some inheritance here, so I'm going to start making a number of protected variables so I can use them in child classes. So again, I thought, well, what are some of the properties of just any easing type, regardless of the actual implementation of the easing type? We need to know where we're going from. We need to know where we're going to. We need to know how long we want that ease to go for. And then we also need to know a few other things because I'm adding some utility to it. I need to know the elapsed time internally for any sort of counter I'm using. And I'm also actually able to start running my ease with a delay, so I also am able to provide a delay. I am going to create a coroutine variable so I can track my coroutine. I'm going to have a reference to a mono behavior because my mono behavior is going to run that coroutine. I need to know what type of ease this is going to be, if it's ease in or ease out, so that's going to be my type variable. And then I have 2 variables that I'm going to look after and that are going to change during the runtime of the actual object. So I have 2 here. I have protected bool is easing and protected float value. So these are the sorts of variables that I felt I needed to adequately run the class, regardless of how the actual implementation of the algorithm to ease the object would work. So the first thing I did was I created my constructor. So public easer. And as I've said, I have thought a little bit about what sorts of things I need to know to create an easing object. So the first things I need to know are where we're going from, where we're going to, for how long, whoops, from duration, float duration, and then what type of ease that is. Now keep in mind I'm using floats, so I can ease in one axis of an object, or ease anything really. I can ease colors, I could ease anything. That's the reason I'm using a float. You could write an easing class that uses a vector 3 or something else if you want to ease just in three-dimensional space, but I like that this can be applied to just about anything. So now what I need to do is quickly set these up. This dot 2 is 2. It's probably a better way to do this, but I'll do it the long way. And then I'm going to do a few other things. I'm going to set the object to initially not be easing, because this doesn't explicitly run as soon as you call the class. You actually have control over when you want to start running the ease, so you can set your ease up in code and then run it later. So I can now just say that it's not easing. Its current value is the from position, because we haven't moved anywhere yet, and the timer is set to 0 because we haven't started running. So value is basically the value of the object's position relative to, I guess, the start value. These are absolute values, they're not incremental values, but value will be whatever the current value of the ease is, and obviously before we run it, it's set to the initial position. So how do I want to do this? It's probably easier for me to do all the, I guess, helper methods first. So I did make a few helper methods. So we have public void pause ease, which, as you can imagine, pauses the ease. So basically, I just have a check here. If m does not equal null, because if we have a null mono behavior later, it means that the coroutine isn't even running. So this is just an easy way to check that. And we say m.stop coroutine, and our coroutine we named earlier is routine. Oops, routine. And we're going to say it's no longer easing because we've paused our ease. I've called that coroutine, haven't I? Routine. So that's allowed us to pause our ease. Now, pausing is cool, but I also thought it would be nice to be able to stop the ease. So what stopping the ease does is it pauses the ease, but it also sets the value of the object back to its initial position. So stopping the ease is, I guess, essentially what it actually does, I'll say, is stops and resets the ease. So what I can do here is, let's say I've got an ease that eases from its position to another position and then back again. It's like a recyclable animation perhaps, or perhaps it eases off screen and we want to reset it so we can use the same animation again later. Once the ease is done, I can just call stop and it resets the ease. I guess the other thing I would need for that is to set the elapsed time to be 0 as well. Otherwise, we might have a few issues later on. We also have another public function which returns a boolean called isEasing. isEasing. And basically all I'm doing for this is I'm returning whether or not we're easing the object. So isEasing is going to be used when the ease is running. And and I'll show you why that's useful later. We also need a function or a method to actually get the value. Which gets the value of the e's for us. And now, what I might do, because I really can't show you how to run the e's until I think I've written the coroutine. So what I'll do is I'll write the coroutine first, and then I'll show you the rest. So the coroutine is actually private, so we can't actually I'll make it protected so we can override it if we need to. So protected my enumerator, because it's going to be a coroutine called move object. So this is going to be the coroutine that's actually responsible for moving our object. Now I've discussed one of the things that I decided is I wanted to be able to pop a delay in here. So the reason for that is I could potentially stack up a whole bunch of eases line after line, say when you load a menu, and then I can just pass in my delay and that'll sort of queue up but wait the appropriate amount of time and then start running. Now I have a current position variable that I'm going to create here. Current position means current position in the animation. So the current position, I guess, is it's the percentage of the duration time is what I'll be calculating with that. And now I need a loop because I want to run my coroutine over a number of frames, and I'm going to say while the elapsed time is less than the duration, so basically while we haven't reached the end of the length of our ease, then do something. What are we going to do? We're going to calculate our current position in the ease, how far along we are, which is going to be the elapsed time over the duration. And the reason we do that is our current position needs to be normalized between 0 and 1. That's sort of the way these easing functions work, is your time from x is normalized between 0 and 1, 0 being the start and 1 being 100% of the way through the animation, and then the y value on that graph determines the actual output of that function. So now we know how far along the actual animation we are. We need to assign the value of this animation to the value variable so we can get it later in other classes. And I'm going to use a ternary for this because I like ternaries. I will have errors in this code until I implement some other methods, but that's fine. So we're going to be checking our type because we have two cases for our type. It's either going to be ease type in or out. So I'm going to use a ternary and say that easing in equation, current position, or easing out equation. And you'll see that I don't have these implemented yet, so I'm going to get an error, but bear with me. I'll pop them in a second. You'll see how this works. But as you can see, this line is basically doing just a nice, short, neat if statement. It's saying if we're easing in, then I've got a function called easing in equation that will calculate the appropriate ease for easing in and the other one for easing out. We then want to increment our elapsed time because we're doing this over a series of frames. And then we want to say yield return new wait for end of frame. So this will keep running. This loop will keep running until the duration of our duration of our ease is over. Now, because of the way a lot of these functions work, if you've ever seen any sort of ease, there is potential that because things like powers never necessarily reach a certain value due to limits. If you know what limits are in maths, you'll know that sometimes your algorithm will never reach a potential value. So what I do, once the duration of our ease is finished, I always just make sure I set the value of the ease to actually be the final value we wanted. So if for some reason I need to check, say I want to move my cube to position 1, by doing this, I know that the object's position is always going to be 1 at the very end of the ease, and I can actually check those two values explicitly. Otherwise, they might be close, but not identical, and this way I can ensure that they're identical. And just because I don't know what order necessarily these are going to run in, I just wait for one more frame That's a pretty trivial weight there, but that just guarantees that if I'm running in another script, if I'm running this easer, there's a good chance that I'm always going to make sure that this value variable is definitely set to the position that I wanted to go to at the very end. And then is easing is now false because we're no longer easing. You'll note that I haven't set this to true anywhere. I'll show you how I'm going to do that in a minute. So this is basically the code that moves the object. That's all it does. That's just saying change a value based on a certain method, which we haven't implemented yet, as a result of our movement along a timeline. It's probably the best way I can describe that. And the next thing I'll do is I'm going to implement the actual methods for creating the functions, the mathematical functions that we're going to use to ease. And the way I did this is I actually made an abstract class. So abstract classes, you don't implement the functionality. You actually have to create like a child class that extends this, and then add the implementation there. And the reason for that is every function for easing is different. So I'll probably show you a power ease function, which is quite a simple one. But of course, a power ease has different required variables than, say, a back ease or like a bounce ease or something different. So by doing this, I can have the same, obviously, core functionality in the base class. That's the whole point of the base class. And then I can just tweak it as I need for each specific type of ease or function. So I'm going to have a method here called protected abstract float easing in equation, and that takes a float called current position. Because it's abstract, we don't implement it. It's contained in a non-abstract class. Sorry, public abstract class. Now that I've implemented an abstract method or function here, my class also has to be abstract as well. And I'm going to add another one called easing out equation float current position. And the reason there's two, as I said, is because one is the inverse of the other. So this calculates the value of the easing function, and then calculates the value of the ease out function. So now we've got a pretty robust base class already. You can see here we've got the ability to create an ease, move from a value to a value over a specific time in a specific direction. We can pause that, so if we need to actually pause it but then rerun it from its current position, we can do that. We can completely reset the ease if we have to. I can check whether or not the ease is running. I can get the value of the ease. I can move the object, and then I have to implement some extra functionality, but we're missing one more function, and I generally like to sort of order my functions a little bit, and the most important ones near the top, so I'll pop this one, actually I might put this one in between here because they sort of feel relevant. I have one more method, that's public void run ease. So as I said, I don't explicitly run these eases straight away. I actually allow myself to determine in the other scripts when I want to run this easing class. Now, because this move object is a coroutine, I need a mono behavior available to me to run the coroutine, so I call that M. And then I also have my delay float, which I discussed earlier is what allows me to determine when I want to run this ease. I can run it with a delay. So I've decided to make this class like toggleable. So once it's running, it's running. If you keep calling run ease, it won't do anything. I guess you don't have to do that. I've just decided that's the way I'd like to do it. So if you accidentally keep running your ease over and over again, it won't break it and it won't keep resetting it. So once it's on, it's on. So the first thing we need to do is say we're going to start easing our object, so we're going to start moving it. Now I'm going to need this later. So I'm going to set our global version, sorry, our class level version of our mono behavior, which is up here, mono behavior M. I'm going to set that to the mono behavior we've passed in. So our other functions such as stop ease and, well, pause ease, and as by extension stop ease, have access to the mono behavior that started running the ease. I then need to set the delay. So, for example, my coroutine can run a delay. And then I'm going to start it. So I'm going to say routine equals m dot start coroutine. And our coroutine is called move object. And there we have it. So unfortunately, I sort of had to show you all of those things at once, and I want to run through them fairly quickly. I don't want my tutorials to get too long. Some of them have been pretty bloated, but this starts the ease, and this moves the object. So I'm just going to go through this again really quickly. This enum provides the type of the ease, whether we want to go in or out, and that basically just determines the order in which it, I guess, runs the mathematical equation, and you'll see an example of that in a minute. These protected variables are basically all the variables I feel we need to run any type of ease, regardless of the actual mathematical implementation of the function. These two variables are the ones that get changed based on whether or not an easing variable is being run, and if it is being run, what the value of that ease is. So this information from our easer sets up all the information we need for any ease, as I've mentioned. I then use the run ease method to actually start running it, and that's going to create a coroutine. It's going to actually basically toggle this on, so it's on. Once it's running, it's running. It's going to start this coroutine that moves the object. When the coroutine's done, it will alert us that it's no longer easing. And we have two protected methods that we're going to actually implement the maths in for our ease. So that should be saved. I should be able to go over here and get no errors. Fantastic. So what I'm going to quickly do is up here in the top level, I'm going to create a script called test. I'm going to create a cube in my scene, and I'm going to, it's already reset, good. And I'm going to throw the test script on there because the test script is a mono behavior. Now, my easer is a normal C# class, so I'm going to write an easer, or sorry, instantiate an easer called easer. But what you'll notice is if I try to go easer equals new easer, I get an error, and it's not because I don't have all the right formal parameters in there. I'm getting an error because it says I cannot create an instance of the abstract class or interface easer. Now you'll see here, my easer has two abstract functions, two abstract methods. I have to implement these in a child class for me to be able to use it. So what I'm going to do is I'm going to go back into my easing library folder here. I'm going to create a new C# script, and I'm going to call it power ease. So power ease is a type of easer. So I'm going to make this have some functionality now. The first thing you'll note is that a power ease is not a mono behavior. It's an easer. So if we look at our easer class, the four things we need to know for any easer are where it's going from, where it's moving to, for how long, and the type of that ease. But for a power ease, I'm basically raising something to a power. So x squared is a power ease, x cubed is a power ease, x to the 4 is a power ease. So the first thing I'll do is I'll create a private float called power. I need to know to what power do we want to raise our value in order to make it ease. You can see I'm going to have an error in my power ease class for a while, but that will be resolved soon. So the first thing we're going to do is create a constructor for this class called power ease. And what do we need? We need the same things for our base class. So we need from, to, I'm then going to have a power variable. So what power are we raising to? How long do we want that to be? And what ease type do we want? We're going to say that this dot power equals power. So in our child class, the only thing that's different here from our power ease, for our power ease, is that we have a power function. So we need to make sure in our constructor that we're telling the class to obviously make this variable accessible to the whole class because I'll need it later. But I also need to make a call to the base class, to the child class, with what? With from, to, duration, and type. Because by doing that, I'm basically setting up this constructor here. And I've just added in a little bit of extra information in our power ease because we actually also need to know the power for a power ease. Now what I need to do, I need to implement these two methods. And they're not abstracted anymore. They're the actual functions. Do you want to fix that for me now? Does actually. Why do you not want to work for me? Alright, I'll do it the easy way. There we go. I didn't have the override keyword in, sorry. So when you implement an abstract function, you have to provide the override keyword in the child class so we know that we're overriding an abstract class. I'm getting errors because I'm not returning anything. So to return, we're going to do the easing in equation first, and this is really simple to compute. So I'll just write the code in. You can sort of work out how it works. Basically, because these equations give you non-incremental values, I'm basically just doing the math to work out where this next value that I'm calculating falls between our infinite top and bottom values, like to and from values. So easing in, I'm going to do this. This might be easing out. Look, I might have my terminology wrong for easing in and out, so I apologize if that's the case. But that's basically the math for an easing in equation. And you can find equations for these all the time, or you can jump on somewhere like Wolfram Alpha and work one out for yourself. But basically, this is saying from our from variable, so where we're starting from, add the difference of 2 minus from. So obviously 2 minus from would be our from value plus our 2 value. So we're going to get the minimum. So this is the minimum. And this would be the maximum depending on this value. And this value here, this current position value, is getting computed in our eases coroutine. It might sound a bit confusing. I'm probably not explaining it too well, but as current position increases in our coroutine, this is going to create a higher and higher value, and then we basically work out what position that value is between our minimum and maximum value in absolute coordinates, they're not incremental coordinates. And then our easing out equation is exactly the same, except instead of raising it to the inverse power, we just raise it to the power. So here, this is going to, if I'm getting it the right way around, that should start off really quick and then slow down, whereas this one should start fairly slow and increase quickly. So this is a standard, if power was 2, this would be a standard x squared function, whereas this is the equivalent of the square root of x. So they're the inverse of each other. So this is why we can either ease in or ease out. And that's it. Because all the functionality of my easer is in this child class here, it's got my timer, it's got my coroutine, it does absolutely everything I need it to do. The only thing I then need to add in my child class is the actual math to run the ease. So for example, a back ease, instead of having a power here, it actually has an amplitude variable, so I can add in a different equation and get a different type of ease, but still use it in the same way. So if we go back to my test script, I can't implement this easer class because it is an abstract class. However, I can make a power ease class. Now, a power ease class needs a number of variables. The first thing it needs is a from value. So I'm going to say the transform position.y. I'm just going to make this thing move up. Its to value can be transform.position.y, say +2. To what power do we want this to move? We'll say, I don't know, we'll make it x cubed to the power of 3. Duration, let's have it run for, say, 2 seconds, so we can see that it works. And we want an ease type of, we'll start with in, and we'll see what in looks like, and we'll swap it to out later. So you can see that I've created an easer, and I can run my code, it won't do anything. I won't actually do that. The reason it won't run is because we haven't said run the ease. So let's run the ease straight away. The first thing we do is we're going to say, let's actually make this object move. Now, what does a run ease need? It needs a mono behavior, because mono behaviors are responsible for running coroutines. Well, this script is getting attached to an object. We can see up here it is a mono behavior. So let's just pass it this. And that should be fine now. No, it's not fine. Why is it not fine? Because my easer needs a delay. Now, the way I solved this is I'm going to assume that I typically don't want a delay, because if I'm choosing to run something, I probably just want to run it straight away. So what I decided when I wrote this code is I'll just always have my delay as an optional variable, so it's always set to 0 by default. So you can see here I now have an error, and if I want, I could say add a delay. I'm going to add a 2-second delay to make sure the scene is actually running properly, and we can see it work. So I've got this code. I've created a base class, I've created a child class that now has some actual math function in it. And if I run this, should it work? It should work, but you're not actually going to see anything. So I can hit play, I can wait 2 seconds, and nothing happens. That's pretty weird. Why is nothing happening? Because I'm not assigning the result of this ease to anything. So this is independent to this mono behavior, this object. I want to use the values of my transforms position, but I'm not then setting the value to anything. And the reason for that is as I said, might want to make a menu that has like 10 buttons. And so I've got a script that has a bunch of eases in them, one for each object. And then I can assign the output of that ease to whatever I want. And this is why I wrote the easing class. As I said, normally you'd have to set up a timer, something like this, create a coroutine in every object that you wanted to ease, and it's just bloaty and frustrating and annoying, and it shouldn't need to be in your code. So this is why I've made it really simple. I can say if my easer is easing, so if my easer is easing, if it's moving, then let's create a new vector 3 called new position. What am I doing? Vector 3 new position is a new vector 3, and as I've said, I just want to move the object's position in the y-axis, so 0 is going to stay the same. What's y equal to? Y is equal to the current value of the easer. Z is going to be 0 as well. Done. Now, how much easier is that? That's all I have to worry about, because the easing class takes care of all the logic inside it. Like it does sets up the timer, runs it, does all that sort of stuff. So now, when I run this, I should wait 2 seconds, because I've got a 2-second delay. 1, 2, and then you'll see it hopefully slowly move up. No, it doesn't want to do that, does it? Why not? Am I missing something? I apologize. This dot delay equals delay. That should be working. How's about we set our delay to 0? Ah, no. See, this is why you shouldn't be tired. Sorry, everyone. Ah, transform dot position equals new position. Seriously? Sorry, guys. That was really bad. So, we'll wait 2 seconds. 1, 2, and you can see it's moved up. Now, the cube's initial position was 0, and you can see here when I run it, it's going to finish at 2. Now, as I said, this is an inverse power. So the inverse power, y, the square root of x, it starts very quickly, which you can see, and then it slows down quite considerably. Whereas if this was an ease out, because of the math, would have the opposite effect. So it should start off slow and then speed up. So after 2 seconds, we see it start slowly and speed up. But that's really simple because now I've really only got like one if statement check. I don't have to worry about all the other logic. It's always taken care of. And all I have to do is every time I want to come up with a new algorithm is just create a new child class and it's already done for me. I don't have to worry about testing anything else. And to prove that works, if I don't start running the ease, so if I say, oh, I want to create the easing object, but I don't actually want to start running it now, I can click play, and it's just going to sit there all day. It's not going to do anything, which is awesome. So I can now actually trigger the ease based on certain events. So I can set all my eases up at the very start of my object if I'd like to, instead of dynamically doing them, just so I know that I've got an ease for every situation perhaps, and then I can toggle it on, and then I can just check that it works. So hopefully that's a fairly simple tutorial. I apologize if I rushed it. Please let me know what you think, and if you think that this was, I guess, a useful tool, or if there's a better way to do it. As I had mentioned, I'm sort of writing this class for myself because I am interested in easing. I've implemented this power ease and a back ease. A back ease actually extends, if we're using this example, it would extend past its target and then sort of come back a little bit, so it would overshoot its target. And it feels really nice. It looks really good. And now I can just slowly start adding different eases as I want to try and do different things. I'd like to try and add a bounce ease. So let me know what you thought. If you enjoyed this video, of course, please like, subscribe, all that sort of fun stuff. Please leave me some comments. Let me know what you think. Let me know if you'd like to see anything in particular. I've got a lot of uni work to do in the next 4 weeks. It's coming up to end of semester. So if I'm still a bit quiet for the next few weeks, please bear with me, but I do appreciate you watching. I hope you keep coming back and that we can keep learning some fun stuff together. So thank you.